Hello everyone. In this video, I'll be solving demo problems 1 and 2. Demo problem 1 is asking this question, which is how many people ride the bus. Clearly we need the information from the boarding table. Specifically, we have to narrow down to the daily boardings column. Let me switch over to the Jupyter Notebook session. Here is the output from the last query that we executed, which is select star from boarding limit 5. Recall that star indicates that we need to extract all the column information. As part of the from clause, we are mentioning the table name as boarding. We also have a limit clause and we specify 5. That's going to limit the number of rows as part of the output of the SQL query as 5 here. We have a lot of useful information as part of the boarding table, including stop ID, route number, lat long geolocation of the stop, along with average daily boardings. Before we solve this problem, I'm going to introduce to you a new syntax, which is open triple double quotation and close triple double quotation. That's going to enable us to split a string into multiple different lines and format it in a neat way. Let me define a variable called QRY. I'm going to type open triple double quotations. Observe that Jupyter Notebook automatically typed the close triple double quotations for me. If I go ahead and press enter here, I'll be able to format my query in a neat way. Let me type the shell of the query by typing select something from something. Clearly, for the from clause, we'll have to mention boarding table. For the select clause, we are going to specifically narrow down to daily boardings column. Let me execute this query by typing pd.read underscore SQL. First argument is going to be the query variable, which is QRY. The second argument is going to be the connection object, which is within the variable con. Let me capture the return value into a variable called bus underscore riders, and I'm going to go ahead and display bus underscore riders here. Observe that we were able to narrow down just to the daily boardings column. How do we compute the number of people that get on a bus in Madison every day? Clearly, we need to sum up the daily boardings column here. Recall that you can invoke the sum function as part of pandas data frame by typing data frame variable dot sum open parenthesis close parenthesis. This is going to be the pandas version of the solution here. Looks like we have around 55,000 people board a bus in Madison on every day. Looks like these numbers are from the pre-pandemic era. I am quite confident that we don't have 55,000 people boarding buses in Madison on an average daily basis. Let me show you how you can solve this exact same question just using a SQL query. I'm going to briefly introduce to you summarization. Let me copy the code in input cell 18 and paste it within the new cell. Instead of writing my query as select daily boardings from boarding, I'm going to say select sum of daily boardings from boarding. I'm going to get rid of the sum function call in line number 7 over here. Let's execute this particular query. Observe that we are now getting a data frame where you have the sum column value for row index 0 as the exact same value that we got as the output from the pandas data frame sum function call. In next lecture, we are going to pick up the summarization techniques and we'll be covering a lot of examples. Let's move on to demo problem 2, which is going to be about finding the westmost bus route within city of Madison. If you keep going west, you're going to end up getting smaller and smaller longitudes. If you want to keep going east, you're going to get bigger and bigger longitudes. Let me switch over to the Jupyter Notebook session. Clearly, we need the information from the longitude column here. I could either say select longitude from boardings and apply other clauses, or I could extract all the columns and work with that as well. Let me show you that both of those will produce the same output. So I'm going to say select something from something. From is going to be boarding here. For now, I'm going to use star as my select clause, which is going to select all of the columns within the boarding table. Let me go ahead and invoke the read underscore SQL function by passing QRY as the first argument and CONN as the second argument over here. Observe that we are getting all of the columns. What do we want to do here to solve this particular question? We want to be able to find the smallest longitude in such a way that we are able to find the westmost bus route details over here. Since we want the details associated with the bus route, it is essential that we use star as part of this query. If I were to use select lawn from boarding, we are going to end up eliminating all of the additional column information here. So I'm going to switch back to the select star version over here. Let me tell you how to solve the rest of the question, which is about finding the smallest longitude value. Clearly, we'll have to order the rows here using order by clause. What do we want to order by? We want to be able to order by the longitude column, which is going to be LON here, and the default order is going to be ascending, or you could alternatively just mention ASC. Let me remove the ASC keyword and show to you that you're getting the exact same output. Observe that you're getting the exact same output here. We just need to limit the result of our query here by 1 in order to find the westmost bus route, which is going to be route number 55 here. Let's copy and paste this lat long into Google Maps so that we can look at the westmost location point within city of Madison where we have bus coverage. Looks like this is closer to Epic campus over here. That'll be it for today's lecture. There are additional challenge demo problems which you can go through on your own time. I would also encourage all of you to try out all of the queries that we covered as examples as part of the slide deck.